Alright guys, so we're going to go ahead and start today off with a bell ringer. I want to talk about the difference between the first two problems. Number one, or the one on the left, everything is inside the natural logarithm, versus the second one, where the natural log is being multiplied to a polynomial, or in this case, the 6x cubed. Okay, sorry if I don't put her in my lap, she's going to freak out. So, because the first one is has everything to the natural log, I can go ahead and do the natural log properties, which means that I have the 3x being multiplied with the square root of x squared plus 4. So I can go ahead and split that up by taking the natural log of 3x plus the natural log of 4x plus 1 to the half. And we'll approach the second one here in a moment once we get finished with this first one. So we know we need essentially u's for each of these pieces. So I'm just going to call the first one u, which are going to be is 3x. And we need the derivative, which is 3. And we're just going to say this one is v, which is 4x plus 1, and dv, which is 4. Now, the reason I'm doing that is since I'm doing it two different pieces, just two different letters, so we don't get confused. And since we're being asked to find the derivative of the natural log is the derivative of the inside, which is in this case, first part 3, over the original, which is 3x, plus, back up. Remember, exponents come down as coefficients, so I'm going to have the 1/2 times the derivative over the original. Go ahead and simplify this guy. My 3's cancel out, so I'm left with 1 over x. 4 can be divided by 2, which will give me 2. And then I'm left with 2 over 4x plus 1. And that's my answer on that first one. Now, the second one, I already started by saying that they are different because I'm not taking the natural log of both pieces. So what I'm going to have to do is product rule because I have two things being multiplied together. So when I have that, I need to already get ready to go ahead and do my u and my du because I have the natural log of something more than just x. So my u is going to be 4x plus 2, and my du is going to be 4. So product rule tells me I have the first guy, which is 6x cubed, times the derivative of the second, which is 4, over 4x plus 2, plus the second, which is the natural log of 4x plus 2, times the derivative of the first, which is 18x squared. And I'm going to go ahead and simplify it like I did before. So I'm going to go ahead and multiply the 6 and the 4 on top. And I get the 6 times 4 is 24, x cubed over 4x plus 2. And then just like when we worked with chain rule, we're going to go ahead and bring the polynomial up front, which will give me 18x squared times the natural log of 4x plus 2. And if you wanted to divide everything in this first term by a factor of 2, you could. So you would get 12x cubed over 2x plus 1 plus 18x squared natural log of 4x plus 2. So, same thing. Okay, today we're going to go ahead and start working with compositions. Now, I know you've seen these in the past, but we really need to have a good understanding of them to understand the rest of this section. So we're going to go ahead and refresh our memories on how to go ahead and do compositions. So first things first is I'm going to go ahead and do everything from the inside to the outside. So what I like to do is I'm going to take a look at what I'm putting in. And what I mean by that is what is the guy that's inside. So in this case, it's my g of x. So I'm going to leave my f alone for a minute because he's on the outside. And where it says g of x, I'm going to go ahead and just replace it. Oops, not what I want to do. With just my 6x plus 7. So I'm going to have f of 6x plus 7. And my parenthesis did not look great, so let's try that again. And essentially what I'm trying to do here is take that 6x plus 7 and plug it in to my f. So my f of x, excuse me, is 3x plus 4. So every time I see an x, I'm going to have the 6x plus 7. I'm going to go ahead and simplify. So I get 18x plus 21 plus 4, which gives me 18x plus 27. Why did I write 27? Sorry guys, I really have no idea where that came from. I even have a 5 on my notes. Okay, goodbye cat. Ow. Or not. Now, on this second one, again, we're going to start by going with the inside out. So my inside here, in this case, is the f of x. So I'm going to go ahead and replace it with the 3x plus 4. So I have g of 3x plus 4. And then again, I'm going to plug that 3x plus 4 in for my x. So I have 6. And I'm going to switch colors here. So I have 6 times 3x plus 4 plus 7. Again, going to multiply that through. So I have 18x plus 24 plus 7, which gives me 18x plus 31. So if you notice, while I did the opposite here between the first and the second example, they are similar, but not the same. So that's one of the big key, like, ha la 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 la, take a look at me things, is that even if we are asked to flip-flop them like we are in this one, they're going to look similar in some instances, but they will not be exactly the same because I'm asked to do the orders in a different way. Let's go ahead and try next one. So again, we're going to go ahead and do these two compositions. Still looking at the inside out. So in this one, first one, I'm going to look for g of x. So I'm going to take my 3x plus 6. So I have f of 3x plus 6. And my f of x here is x squared. There we go. So I have my x squared plus 5. So yes, we're going to go ahead and square this guy. I have to do the multiplication first. So 3 times 3 gives me 9, so I have 9x squared plus 18x plus 18x, I'm going to go this way, plus 36 plus 5, which results with 9x squared plus 36x plus 41. Taking a look at the second one, though, I'm going to plug my f of x in. I thought I highlighted too much there. Excuse me. So I have g of x squared plus 5. And my g is 3x plus 6. So I have 3 times x squared plus 5 plus 6. So I get 3x squared plus 15 plus 6, which gives me 3x squared plus 21. Again, these ones are not even that close to begin with. The other ones, like I said, were sometimes they're going to look similar, or at least they're going to have the same degree of polynomial. So, for example, the first two both had the answer of a 1-degree polynomial. They're a linear. They just have a simple x. These two will both have a squared or a quadratic because they both have the x squared. Okay, let's try the next two. Now, these ones look more complicated, but the steps are exactly the same. We're going to go ahead and take a look at what's in the middle. Again, going to do g, which is 7x plus 4. So I have f of 7x plus 4. And I'm going to go ahead and plug that in for my x. So I have 1 over 2 times 7x plus 4 plus 3. And I don't like how my fraction's not nice and even, so made it nice, a little bit longer. So I have 1 over 14x plus 8 plus 3, which is 1 over 14x plus 11, which is as simple as I can go. Same idea here. Inside's going to be my f of x. So this time I have g of 1 over 2x plus 3. And my g is 7x. So I have 7 times this guy plus 4. We try and ask ourselves, can I go ahead and simplify anything with those fractions? 7, 2, and 3 don't have anything in common, so I'm just going to go ahead and multiply on top. Because a whole number times fraction is just the whole number times the top. And we're not going to worry about getting common denominators here. So I have 7 over 2x plus 3 plus 4. Excuse me. All right, these are our last two examples. Now, if you notice on these last two, they both have an extra part to it. We are going to first approach this like we have done the other ones. And then what we're going to do is once we get our final answer or an equation, so for example, like the circled ones, either the red or the green, we're going to go ahead and plug in whatever that value is. So in this case, the first one we're going to plug in 2. In the second one, we're going to go ahead and plug in 3. That being said, I have my f, and inside f is going to go g, which is 8x plus 2. And my f is the square root of 6 times 8x plus 2 plus 5. I'm going to go ahead and simplify that. So 6 times 8 is 48, plus 12, plus 5, which is the square root of 48 plus, excuse me, forgot my x there, which is the square root of 48x plus 17. And then at this step, we're going to go ahead and plug in our value of 2, because that's what we're asked to plug in. So I have the square root of 48 times 2 plus 17, which gives me the square root of 113. Then I gotta try and ask myself, can I simplify that guy? Nope. So he's just the square root of 113. Okay, now we're going to go ahead and do the opposite, and we're going to work on plugging f in. So that is the square root of 6x plus 5. Check that again. So my g is 8. So I have 8 times the square root of 6x plus 5 plus 2. And all I can do there is multiply the 8 out front, because I cannot multiply underneath the radical. So I get 8 times the square root of 6x plus 5. And in this one, we're going to go ahead and plug in the value 3. I'm trying to find a color that's dark enough that you guys can see. So then, once I plug that in, I have 8 times the square root of 6 times 3 plus 5. And I realized I was way too close to the one I used across. So I'm trying not to get those confused. So I have 8 times the square root of 23 plus 2. The square root of 23 cannot simplify down. So I have 8 square root of 23 plus 2. Alright, and your homework is your worksheet.